All right, in this video we're going to go over 3.15. So you will need pages 372 through 374. If you don't have those, you should go grab them. 372 through 374. All right, so we're going to start off here looking at some salaries, and we're going to be analyzing how long it takes someone to work to have to pay for a tank of gas. So clearly that's going to depend on how much you make per hour. In fact, the higher the annual salary, the blank time the person will have to work to pay for the tank of gas. What do you think? Higher the salary, the blank time the person will have to pay. That's going to be the less time it will take. Okay, so the more money a person makes, then it's going to take less time to work to pay for a gallon of gas, or tank of gas. So we're going to investigate the question for the following salaries. So here we have a bunch of salaries. We have the 10 highest starting salaries and lowest. This is from 2010-2011. From a college salary survey, so these are probably a little, not a little, they're probably lower than what we could expect to find today, but they're the numbers that we're going to use. All right, let's make this a little bit bigger here. So some assumptions have to be made before we can begin to answer this question. Let's assume the gas tank holds 20 gallons and that gas costs $3.50 per gallon. A, if we assume a larger tank, what would happen to the number of hours people must work to pay for a tank of gas? And B, if we assume a higher price, what would happen to the number of hours? So maybe pause the video and answer these two questions. All right. So if we had a larger tank, then they'd have more gas to buy. So what would happen to the number of hours? It would increase. The number of hours would increase. You could write that as a complete sentence, would be nice. If we assume a higher price per gallon, that means they'd have more money to pay, right? So they'd have to work longer. So what would happen to the number of hours? I'll model good behavior and write a complete sentence. The number of hours worked to pay for a tank of gas would increase. There's good behavior. That's the same sentence up there. All right, question number 2. Assuming that each person works 40 hours per week and 50 weeks per year, convert the annual salaries given in the table to annual salaries. What operations are needed to do this? Record the hourly salaries. That's hard to say. Hourly salaries in the table that follows. All right, so we're going to do that here. Let's go ahead and skip to this table and take a look. Let's think about how we're going to figure this out. So we've got our petroleum engineer, and we've got their salary over here. It's $93,000. And they're going to work 40 hours per week, 50 weeks per year. How much do they make per hour? And so how are we going to figure that out? What operations are needed to do this? So we'll just kind of jot that down over here. Well, first we're going to have to figure out how many hours per year they work, right? How many hours per year? So they work 40 hours per week and 50 weeks per year. All right, so we can actually multiply these two rates together, and we can keep the units here. We could see that this week is in the denominator, this week's in the numerator, so these will cancel. And if we multiply these rates together, we're going to end up with hours in the numerator and years in the denominator. So that's going to tell us how many hours per year they work. So 40 hours times 50 weeks is 2,000 hours per year. So So what are we going to do? Well, we're going to take their annual salary. So they make $93,000 per year. That's for our first person here, our petroleum engineer. And we are going to divide that by 2,000 hours per year. Now, I know it's a little bit weird to leave the units in here, but I really want to show you guys how cool this is when you work with the units. Remember, when you divide by a fraction, you multiply by the reciprocal. So if I change this to multiply by the reciprocal of this, that's going to change 2,000 to 1 over 2,000, and it's going to change my hours per year into years per hour. I flip that over also. So in this case now, I've got years in the numerator and years in the denominator, here and here. So I can cancel those out. For the numbers, I'm going to do 93,000 times 1 over 2,000. That's the same as 93,000 divided by 2,000. So let's get our calculator and do that. 93,000 divided by 2,000. That's 46.5. 46.5. Now, what units do I have left? Well, I have dollars, and then I have hours in the denominator. So I have dollars and then hours in the denominator, $46.50 per hour. So we can go over here and we can say $46.50 per hour. I'll just leave that without the dollar sign because we have the dollar sign right there. So no matter what the salary is, no matter who the person is, it's still going to be 2,000 hours per year. So we're going to end up taking whatever their yearly salary is and dividing it by 2,000, and then we're going to have the dollars per hour. Okay, so let's pause right here and let's just fill out this column. This is going to take a little while. All right, so I want you to fill out this column here, take all of the salaries, divide them by 2,000, all the yearly salaries, divide by 2,000, and let's fill out this chart. So pause the video right now and go ahead and do that. All right, take a look at those numbers. You could pause the video again and see if you got those numbers, but hopefully you went through the process there just to make sure you have it. All right, so now we have how much they made per hour, and what we want to do is figure out how many hours they'd have to work to pay for a tank of gas, right? So if I'm an applied mathematician here and I make $28.20 per hour, how many hours would I have to work to pay for a tank of gas? Hopefully the question that you're asking yourself is, well, how much does the tank of gas cost? That's what I need to know, right? So let's go back to problem number 3. To find how many hours of work will be required to pay for one tank of gas for each field of work, first we're going to have to calculate the cost of a tank of gas. Well, we need the information about the gas. Here it is up here. We got 20 gallons in the tank and it's $3.50 per gallon. Okay, so we got 20 gallons in the tank times $3.50 per gallon. Notice the gallons. I've got one in the numerator, one in the denominator. Those will cancel, and I'll just be left with dollars, which makes complete sense here. So 20 times $3.50, what is that? 60, 70 bucks? All right, so $70 per tank. That's how much it's going to cost. Write the operation you will use to calculate the time required to pay for one tank of gas. So if it costs $70 per tank of gas, and let's look at our applied mathematician here. They make $28.20. If they make $28.20 per hour, then we're going to have to divide, right? We need to see how many 2820s go into there. let's follow. I know this is not your favorite thing, most students, to follow along and keep the units in there and go down this rabbit hole with these units, but I really want you to see how they work if I haven't mentioned that already. So remember, dividing by something is the same as multiplying by the reciprocal. So if I change this to the reciprocal, I'm going to have hours on the top now, and then I'm going to have dollars down here. Okay, so now notice what's going to happen. I've got dollars in the numerator and dollars in the denominator. So those are going to cancel. The dollars are going to cancel out. My unit left, my units of measurement, are going to be hours on the top and tank on the bottom. What does that say? Well, that's going to say hours per tank. That's how many hours I'm going to have to work per tank. And then to get that number, I'm just going to divide 70 by 28.2. And that gives me, I'll round it to the nearest hundredth, 2.48 hours per tank. All right, I'm going to have to work 2.48 hours per tank. So let's go over here and fill that in. And then we're going to have to do that with the rest of these guys. Well, let's use a different color. How about blue? So here we've got 2.48 hours per tank. So we're going to do this for everybody. What did we do? Let's go back and look at it again. We took the $70, so that's fixed. For all these people, no matter how much they make, the tank is still 70 bucks. But then we're going to divide that by their hourly salary, and that will tell us the hours per tank. Okay, so you don't have to go through all this with all the units of measure. Just take 70 bucks divided by 70 bucks divided by their hourly salary. All right, so 70 divided by 46.5 is 1.505. So that's going to round up to 1.51. So the petroleum engineer only has to work an hour and a half to pay for that tank of gas. The applied mathematician is going to have to work almost a whole extra hour just to pay for that one tank of gas. All right, go ahead and pause the video and complete the table. Take a look at those numbers. See if that looks like what you got. Pretty striking, actually, that the highest salary on here, the petroleum engineer, has to work an hour and a half to pay for a tank of gas, and the lowest salary, the child and family studies, has to work almost 5 hours to pay for that same tank of gas. That's pretty striking. So what we want to do now is we want to compare the relationship between the salary, hourly salary, and the hours worked. So we're going to look at these questions here, that relationship between the hourly salary and the tank of gas. So let's just look at these and let's think about some of the types of relationships that we've talked about. Linear, inverse, direct. Okay, so first of all, let's see, do we have something that looks linear? Do we have something that looks like inverse variation? We could look at the table, see what's happening with the numbers. It's a little bit hard to compare. Some of these numbers are kind of difficult to look at, but you can get a general idea. We could also think about how we got this value right here. How did we get the hours worked? Let's see, where could I write this? Let's write it over here. How did we get this number? Well, we took the hourly salary and we took 70 and divided it by that number. And that's how we ended up with the hours that they would need to work. Let's assign some variables. Let's say W for the hours to work. We don't want to use H for both of these. How about W for this? And then S for the salary. Okay, so how did we get W? How did we get this W number? We took 70 and we divided that by the hourly salary, right? 70 divided by that gave me the work. Okay, now looking at that equation, what kind of a relationship do we have here? Is that linear? what we're going to do here in a minute is we're going to plot this information. We're going to take the how much they make per hour. That's what I need to be saying. How much they make per hour instead of hourly salary. How much do they make per hour? We're going to plot that on the horizontal axis, the input, and then the hours that they need to work on the output. What is that graph going to look like? Is it linear? With an equation like that, is it going to be linear? All right, hopefully you're saying no, it's not linear. When we have an equation that looks like this, where we're dividing by a variable, we have inverse variation. So if we're going to write a model based on the type of variation using k for the constant and using meaningful variables, we would say that the hours that they have to work to pay for the tank of gas, actually I want to write this out as a sentence first. I like this idea. So the hours to work for a tank of gas, hours to work for a tank of gas varies inversely as the hourly salary. Okay, so now if we were going to make an equation for that, we would say the hours they need to work varies inversely, and we'd use k for this constant, as how much they make per hour. So with our model, we can include the value of the constant. We can include this value of k, which was $70, which was the cost of a tank of gas. And if that tank of gas value cost changed, you know, we could modify our model. If it changed to $100 to pay for a tank of gas, we could modify this model. So the variation constant in this case is the 70, and it stands for the cost of a tank of gas. All right, so what we have here is an example of something called a rational function. An inverse relationship is an example of a rational function. But a rational function just doesn't have to be an inverse relationship. Like, here's an inverse variation, that's a rational function. Here's an inverse variation, that's a rational function. This one looks a little bit more crazy. I'm not a huge fan of this explanation here, but let's read through it and I'll modify it. A rational function is a function that can be written as a ratio or a fraction. The numerator and the denominator of the function must both be polynomials, and the denominator cannot be 0. So a couple of things that I want to highlight that I would emphasize is it has to be written as a ratio or a fraction, but I would say that there has to be a variable in the denominator. That's really the key. There has to be a variable in the denominator. All right, so notice I've got a variable in the denominator, a variable in the denominator, a variable in the denominator. And it's okay if there's a variable in the numerator as well, but in order to be a rational function, there has to be a variable in the denominator. And with a rational function, we're going to get this kind of a curvy shape. It's not exponential decay, if you guys have studied that, but it's similar to that in the shape. So last thing I want you guys to do, and I'm going to have you finish this up on your own, pretty sure you can do it here, is this graph. So which variable is independent and which variable is dependent? The independent variable is always on the x-axis or the horizontal axis, and the dependent variable is always on the y-axis or the vertical axis. Okay, so now what you guys can do, and there's a lot of data points here. You don't necessarily have to plot them all. You know, you could do every other one and get a pretty good idea of the shape here. If you feel like doing them all, that's great. So I'll do the first point for you. 46.50 is my input. That's my salary per hour, and then 1.5 So I'm going to go 4650 is about over here. 1.5 is about right there. I'm having trouble. There we go. 1.51. So that's my petroleum engineer right there. All right, so I want you to do that. I want you to plot the rest of these and kind of fill that into that smooth shape. And you should see some kind of a curve like that. All right, I think that wraps that up. So as soon as you get that graph done, go ahead and upload your work to Canvas.